Hi to all. Now I am going to explain VI relationship of passive elements. Before going to give passive element VI characteristics, we can consider basically what are the formulas included in that VI relationship. So we can consider mainly current and voltage, current represented with I, and it is the ratio of charge per time. It is the ratio of charge per time. Actually, it is also defined as flow of free electrons, call it as current, electricity. So it is also the ratio of charge per time. So what is the unit of charge? So charge is coulomb and time is second. So 1 coulomb per 1 second gives 1 ampere of current. Okay. So now what is the unit of current here? Unit of current is ampere, denoted with A letter. A is ampere. Now coming to voltage. So voltage. So voltage, it is also denoted with VRE. Now it is the potential difference between any 2 points are also determined as it is the ratio of work done per unit charge. Work done per unit charge. So work done. So work done per unit charge. Work done per unit charge or charge. Okay. So represented with W by charge denoted with the Q letter. Charge is denoted with the Q letter. So now what is the unit of voltage? So here what is the unit of work done work done per unit charge? What is the unit of work done? Joule. And what is the unit of charge? Coulomb. So 1 joule per 1 coulomb gives 1 volt. 1 volt. 1 volt. Okay. So now the unit of voltage is volt, represented with V. Okay. Now coming to third one, that is power. So power is the ratio of work done per charge. Work done per time, not charge, work done per time. So work done is represented with W and time is T. So what is the unit of work done? That is joule per second. So 1 joule per 1 second gives 1 watt of power. 1 watt of power. Okay. So now what is the unit of power here? Unit of power is watt or kilowatt or megawatt. Okay. Now these are the main main definitions regarding current, voltage and power. Now consider energy. Okay, represented with E. So it is nothing but product of power into time. If we are changing time, we are considering change in time, we can consider integration. So we can apply integration here, we can consider dt. Okay. So from 0 to t, p dt gives the energy value. Okay. So what is the unit of energy ma? It is measured in terms of joules or kilocalories, or normal unit is calorie, or kilowatt hour. Okay, these are the units of energy. Okay, so now coming to current, so we can write it as I equals to dq by dt. Okay, change in charge per change in time. And voltage also we can write it as V equals to dW by dQ. And power. So power also P equals to dW by dt. P equals to dW by dt. So P equals to dW by dt, that is nothing but we can write this value dW by, I am considering dq here, and in numerator part also I am considering dq, and dt is as it is. Okay, so now dq get cancelled, finally we get dW by dt. Now here P equals to dW is nothing but what? dW by dq is nothing but voltage. dW by dq is nothing but voltage. Now dq by dt is nothing but what? Current. So power P equals to V into I. Product of voltage into current. So the basic formula for power is work done per time. Based on that only we can consider P equals to V into I. What is the unit of power? Power equals to 1 joule per second. It gives watt. Okay. So this is the basic information about current, voltage, power and energy. So based on these quantities we can consider VI relationship of passive elements. So what are the passive elements ma? Resistor, inductor and capacitor. So now we can consider voltage equation, current equation and power equation as well as energy equation also for each element. So first of all I am considering resistor. Okay, first of all I am considering resistor. So now according to Ohm's law, V is directly proportional to I. So V is directly proportional to I. From that we can consider V equals to R into I. R into I. Voltage expression completed. Now coming to current. From this equation I equals to, what is the formula ma? V by R. So current equation completed, voltage equation completed. Now current and voltage gives power. So P equals to V into I. Okay. Now V is nothing but R into I. Already I is there. Consider I. So P equals to I square R. What is the unit of power? Watt. Okay. Now again P equals to V into I. So what is V? V is nothing but what? R into I. Already we substituted here. Now I am considering I value here. So V as it is. I is nothing but V by R. So P equals to V square by R watt. So these two are also same formulas to calculate power in pure resistive circuit. Now coming to energy. So energy equals to integration of P into dt. Okay. Ledu, otherwise I am considering directly E equals to P into T. Okay. So if varying of time we can consider 0 to T dt. Here I am not considering any time period. So directly I am write it as product of power into time. So E equals to T is nothing but here we can write it as I square R or V square by R. So suppose I am writing V square by R into T joules. This is the energy dissipated. It is dissipating element, not storing element. So this much of amount it can dissipate in the form of heat. Okay. So resistor completed. Now coming to inductor. Okay. Coming to inductor. So for this inductive circuit, so we can consider a twisting coil performs or exhibits inductive property. So now I am applying some voltage to this inductor. It produces some self flux. It is directly proportional to current. Okay. So now So now here some current is flowing. Now according to Faraday's laws, V is equals to, we can write it as L into d pi by dt. But pi is directly proportional to I. Directly I am considering V equals to L into di by dt. V equals to L into di by dt. V equals to L into di by dt. Okay. So voltage expression completed. Now coming to current expression. So how can we consider current expression from this? Just here L is multiplying. Coming this side, we can consider V by L equals to di by dt. Now we can apply integration on both sides. Okay. So now I am considering integration. So here L is constant. Directly I am writing 1 by L integration of V dt equals to integration of di by dt into dt. So here differentiation, integration both will get cancelled, will get current here. And this formula is same, that is 1 by L into integration V dt. So this is the current expression in an inductor. Voltage we got, current we got. Now consider power. So power we already know, that is voltage into current. Just to substitute voltage and current expression of an inductor, then we'll get the power in terms of watt. Now coming to energy. So energy stored. So inductor which stores the energy in the form of electromagnetic field. It stores the energy in the form of electromagnetic field. So how much amount of energy it may store? So based on the energy principle, so E equals to integration P into dt. Okay, so now integration. P is nothing but what is the formula ma? Vi into dt. So E equals to integration Vi into dt. So now I am substituting V value here. So E equals to integration. V is nothing but what? L into di by dt. Just writing V value here, and already it has I into dt. So I into dt. Okay. Dt get cancelled. Okay. So E equals to, L is constant term, take outside. So L into integration. I is the constant. So I into di. Okay. So integration of x dx formula. So integration of x dx is nothing but x square by 2. So from that mathematical expression we can consider E equals to L into, that formula is x square by 2. Now here I into di. So I square by 2. I square by 2. So E equals to half Li square. So this much of energy stored in a inductor and inductor. Okay. So inductor, voltage, current, power and energy. Okay. 4 factors completed. Now coming to third element, that is capacitor. So capacitor, it is having two parallel plates. One is positive, another one is negative. So here I am applying some voltage to this capacitor. These two plates are separated with an electric media, dielectric medium. Okay. So now here some amount of current is passing. That current is always opposes the sudden change in voltage. So that current is equals to C into dV by dt. It always opposes the sudden change in voltage. So current expression completed. Now coming to voltage. Same, previously we are considering application, means consider the integration. Here also we can apply integration on both sides. Then we'll get here I by C equals to dV by dt. Now I am applying integration. Now I am applying integration on both sides. We'll get a V voltage here. Okay, so V voltage. This is V voltage, and here 1 by C into integration I dt. Okay, this is the voltage expression in a capacitor. So current expression completed, voltage expression completed. Now coming to power. So power, P equals to V into I, that is the voltage and current, multiplication of voltage and current, then we'll get the power. Now coming to energy, how much amount of energy it is storing, that is half integration P into dt. So integration P is nothing but Vi into dt. Okay, so E equals to integration Vi into dt. Now substitute V value as it is. Just substitute I value here. That I value is nothing but C into dV by dt. So C into dV by dt. Already dt is there. So dt get cancel. So now E equals to V, C is constant, take outside, C into integration V into dV. Okay, so again integration x dx, that is nothing but x square by 2. So from that expression we can, from that formula we can consider E equals to C into here V square by 2. Okay, so now energy equals to half CV square. So this much of energy stored in a capacitor. Okay, so now resistor, inductor, capacitor. Okay, so here capacitor, this is capacitor, here some amount of current flowing. So this is capacitor element, this is inductor, this is resistor. So in each case we can consider the voltage, current, power and energy equations. So in this, resistor is dissipating element, remaining two are the storing elements. So inductor stores the energy in the form of electromagnetic field, capacitor stores the energy in the form of electrostatic field. Electrostatic field. So how much amount of energy it can store? Half CV square joules, and inductor half Li square joules. Now based on this mathematical equations, we can consider, we can tabulate, we can conclude final VI relationship of passive elements. See, so here we can consider the voltage. Now I am writing the voltage current relationship of passive elements. So VI relation. Okay, in passive elements. So now consider element here, element. Okay, now voltage measured in volts. Okay, now coming to second one, current measured in ampere, denoted with A letter. Now third one, power. Power measured in watt. Okay, last one, energy. Last one, energy measured in terms of joules. Measured in terms of joules. Okay, so first element is resistor. This is the symbol of resistor. Unit is ohm. Already we know. Now voltage expression, V equals to R into I. Current expression of this resistor, I equals to V by R. Now power equation, P equals to V into I. Now energy, P equals to integration of P into dt, or otherwise P into T, directly P into T. Energy E equals to. Okay. Now coming to second element, that is inductor. Okay, represented with L, and this is the symbol of an inductor. and unit is Henry. Okay. Now, inductor, what is the voltage? V equals to L into di by dt. Okay. Now, coming to current, current I equals to 1 by L into integration V dt, integration V dt. So, power formula is same as it is, P equals to V into I. Just to substitute these two, then we'll get power. Now coming to energy, so E equals to how much amount of energy it can store? Half Li square joules. And last one, that is 3, that is capacitor. So capacitor is denoted with C, and it is the unit of capacitor is farad. Okay. Now voltage in this capacitor V equals to 1 by C into integration I dt. Okay. Now coming to current, current I equals to here C into dV by dt. Okay. Same power equation, P is as it is, that is V into I. Just to substitute these two, then we'll get the power in terms of watts. Now coming to energy, energy equals to half CV square, half CV square joules. Okay. So based on previous formulas, we can write overall here of each passive element. So voltage, current, power and energy. Okay. So now what is the final question they are asking? How they are asking is, define passive elements and derive the voltage current equations of each element, or tabulate the VI relationship of passive element. So they can allot those 5 marks for that. So this is the basic information about that total topic, VI relationship of passive elements. Okay. Thank you one and all.